you about today really is, for those of you who don't know, I really like concrete. Driving back from Port Alfred this morning is that new Blue Waters or whatever development, and I just thought, you know what, if I'm Julius Malema, I'm going to ban face brick. I'm adding the face brick. It's bloody ugly. Anyway, so I just wanted to tell you a little bit about concrete. I'm going to look at the vast topic, but I thought let me talk about concrete. Sustainable strategies, as you know, it's the new buzzword, and it shouldn't have really been, because I always believe that good architecture is sustainable architecture. Somehow during the 50s and 60s and 70s, people forgot what good architecture is, and I might be stepping on toes here. But really, good architecture is sustainable architecture. I mean, if you don't know about sun angles and natural ventilation, I'm sorry. Go back to varsity and ask your money back. So, sustainable development, I just want to create a bit of a perspective, and I think it's important to realize that there will be 3 billion more middle-class consumers in the next 20 years. We're currently sitting on 1.8 billion. Now, what are the implications? It means 3 billion more cars, more fridges, more TVs, more waste, more plastic bottles. So, yeah, where are we heading? We're heading, I think, it's getting a little bit dangerous, it's getting a bit hot. And I noticed the hurricanes are getting worse. So, yeah, so what is sustainable development? In short, we're looking at needs. In other words, as humans, we've got basic needs. How do we maintain that as an acceptable life standard? I think the days of gross consumerism is over. I mean, when I think of America and I think of all those fat people, I think they're eating too much. And I think they've got too many TVs. And I think they've got their cars are too big. And I think they can cut down on the amount of throwaway stuff. That includes fast food. So, and the second thing that I just want to say is the idea of limits. What do we look at? It's the capacity of this environment, of this planet to really carry it. And at the same time, I'm an optimist. I say I believe in technology. Technology is going to save our bacon. And I think also the way that as beings, we are becoming socially more aware. I don't think, well, I don't know about maybe my age group, but I recycle everything. I mean, I've even got a worm farm. So even the peels go into somewhere and I take their wee and I throw it in my garden. So, and everything can be recycled. So next time you take a plastic bottle, think twice before you put it in the dustbin, because it's going to end up somewhere in a landfill. So the other thing I think we need to look at is the legislative and the regulatory kind of environment that we are in at the moment. And I think, firstly, there's definitely a renewed focus on energy-conscious design. I don't know about your design lecturers, but I'm sure they're pushing it down your throat. The second thing is to look at how can we create holistic strategies. How can we implement holistic strategies? It's more than just about designing a building with a solar panel on it. And thirdly, it's to look at the critical performance and the efficiencies of construction materials, and of course, accelerating research and the development of new ideas and of new efficient technologies. So that's the kind of framework that I just want to set out. So I want to say to you that firstly, that there are 2 key environmental issues that are currently driving the process. The first one is, how do we reduce the carbon emissions associated with the running of a building? I'm standing here, there's lights, there's air conditioning, well, the building's a bit old, but probably air conditioning. Most of these buildings are like just chewing energy. I was last weekend in Dubai and it was amazing. I mean, in 1975 I had one skyscraper that was taller than 30 stories. There's 920 now. And all of them are glazed buildings, glazing, pumping air conditioning. Obviously it's like 38 degrees and I said it's a very nice cool day. Thank you very much. It gets 50 degrees in summer. But still, and then of course during the construction of the building, how do we reduce the carbon emissions associated with that? So those are the 2 kind of key issues that we need to look at. It's the running and the construction of the building. So we all know about the Green Star rating system, and I'm not going to talk about it in detail. If you don't know about it, I think you should, because that's going to be driving that and SANS 10400 and 204. It's going to be driving the way that you design and the way that you think about architecture. So, firstly, I just want to create the overall framework again. The first aspect is to look at design and management. In other words, how do you design a building that's energy and water efficient in terms of the way that it uses energy to heat the building, to cool the building, lighting, all of that. The second thing is material specifications. We all know, for example, that to produce aluminium takes an immense amount of energy versus, say, timber. And the third one is the emphasis on durability and retrofitting rather than demolition. So I think that's important. I just want to show you this. It's kind of research that was done in Australia about case studies around the benefits of green building. In Australia, the cost of a 4-star building is cheaper than conventional, and a 6-star building is about 6% more expensive. So in young markets like South Africa, we're still looking at a green premium, but prices are decreasing. For example, solar panels are becoming cheaper. And the current premium to construct a green building is between 1 and 10% more expensive. But I think it's important to realize that overall, that it's not so much more expensive. And secondly, that green buildings achieve better investment returns and higher valuations. So when you speak to your developer client, you better have to make him aware of the facts that going green is not a luxury. The other thing is also that obvious financial and environmental benefits is that it's low operating costs. So if if a developer works on a building, they're not only looking at the construction costs, they're looking at the operational costs of that building, say, over 10 years. And obviously they're going to save, the electricity bills are going to be much lower in the way that the operating costs are reduced. The second aspect is that it's higher returns on assets, and generally green buildings are seen as more valuable in terms of property values. And the third thing is that green buildings are viewed as less risky future-proof buildings. I also think it's important to realize that when you look at the recession periods, generally green buildings receive higher rentals, and people tend to stay longer in green buildings than in ordinary buildings. So, and in terms of productivity, you're creating a far more pleasant indoor environment. It's nice for people to work there, so people, in theory, should work harder than, say, in a clothing factory in Bangladesh. And of course, it means that your productivity increases and you retain your staff for longer. So it's a win-win situation. I don't think I have to tell you all of this. I think you are converted already. But I think it's important just to keep that in mind. I just want to look at, again, what life cycle means in terms of whole life costing. And if you look at this little diagram, you can see that if your building's operating energy consumption over its lifetime, if you include the construction energy usage, then 87 to 97% of all the energy consumption is consumed after the building has been constructed during its operational period. So your embodied energy in actually physically building that building is only 3 to 13% of the total energy requirements. So the typical life cycle approach nowadays in terms of sustainable development is where, looking at concrete here, is that you're looking at your concrete production, you're looking at your placing, you're looking at a service period of that structure, and then recycling. And recycling concrete going back into the production of concrete. So nothing ever gets wasted. In fact, in Europe, there is now an absolute premium on demolishing buildings and selling it to landfills. You are not allowed to take building rubble and dump it somewhere. You have to reincorporate it back into your buildings. So, what are the average advantages of having a green building? Is that your energy use is about 30% lower, your carbon emissions is around about 35% lower, Your water usage can be anything from 30 to 50% lower. Now, it's very interesting. I was last week at the WAF, at the World Architectural Festival in Singapore, and every single building, except for a couple from China, and it was interesting, from China, were energy conscious. They all looked at the way to recycle water, but all had living roofs or vegetable gardens in the roofs, but all had some green aspect in the way that integrated to the landscape, and all recycling grey water, and all the buildings made use of natural ventilation and natural lighting. So what are the priorities? Once you've reached, the building has reached the end of its life, what do you do about it? And I think there's a certain sense of priority about a decision that needs to be made. The first one, of course, is to reuse the building and to look at retrofit and city regeneration. And I'm going to show you a little bit more of that later. The second thing is maybe to keep aspects of the structure and to reuse certain parts of the building's components. It could be cladding, it could be certain aspects, but nothing needs to go to a landfill, nothing needs to go to a dumping site. Everything can be recycled and everything can be reused. And finally, is demolition and recycling of those materials. The reality is that modern civilization is built on concrete. It's the second most consumed material after water on this planet of ours. And I think it's important that to note that around about 11% of the volume of concrete is cement, and that cement is considered a vital and strategic commodity. And also that you're looking at cement volumes, it's around about 2.9 billion tons a year. That's quite a lot. So what I want to do is I want to do a little bit of a case study today for concrete and looking at concrete from a sustainability angle. And I want to punt it as a locally made natural product. Firstly, I want to just show you, where am I now? Yeah, I want to show you why Spain is bankrupt. That's a bus station. And I just want to think, I think concrete is the only material that you can take to site and do anything with, unlike steel, or you can have it manufactured off site like precast and bring it to site. So you've got incredible design flexibility. You can do anything with concrete that you want to do. The second thing is, and I don't know if you can see, but this is a kind of a resource efficiency. It looks at the advantages of concrete, and my eyes are so bad, so I myself can't see, but clay brick is sitting right about there, and there's concrete, high-strength concrete, and aluminium is right up there at the bottom, and in between you've got your timber glass, insulation, steel, paint, polystyrene, plastics. So if you look at the overall kind of embodied energy that it takes to manufacture concrete, you can see that it sort of sits in a region more or less the same as clay brick, except that clay brick or face brick is ugly. So, of course, it's very interesting since I've been at PPC, it's very interesting to see how these guys are really pumping in lots of money, lots of research to reduce the energy consumption to produce cement. It's very energy intensive to manufacture cement. It takes about, you've got to burn the clinker at about 1,450 degrees Celsius. So what you're doing is you're taking limestone and sand and iron ferrets, and you mix this stuff up, and it's almost like creating a form of lava. You're creating this liquid stone, which then needs to be cooled down and crushed in order to produce cement. So yes, it is kind of hectic. And if you look at the moment, your general kind of emissions, it takes around about 2% of all the GHG emissions in South Africa is produced by cement production. So how do the cement companies respond to that? The first is to reduce the environmental impact by improved process technology, to reduce the efficiency in terms of fuels, materials, and renewable energy. For example, they now make certain plants where they're burning old tires. They're looking at all kinds of ways, teaming up with the sugarcane industry to use that waste products as a source of energy. And also to look at the future removal of CO2 from the flue emissions. So, with concrete, I think the first of all is, as I said, there is a general drive to reduce the embodied energy and the carbon emissions. As I said before, cement production requires a lot of energy, and the technology advances really, if you can see it, the way that it improves the process. Energy consumption has dropped by 40% since 1962 to produce cement. The second thing is that CO2, embodied CO2, has dropped around about 29%. And I need to put that in perspective. Your CO2 emissions in perspective is like 2% is roundabout of the world's emissions produced by cement production, 50% by operating buildings, and 30% by transportation. Actually, all those trucks running around from Woolworths bringing your fresh veggies, that's 30%. So, alternatives to Portland cement, and I think that's very interesting for you, is that cement can be extended by using industrial byproducts such as fly ash and iron furnace slag, and that's got a dramatic effect on reducing the CO2 per tonne of cement produced, as well as having additional benefits such as better workability, fresh concrete, making it more durable and impermeable. And what is interesting is that all bagged cement in South Africa at the moment has already been blended with extenders, and that these are waste or byproducts which otherwise would have ended up in landfills. So fly ash is basically a byproduct from burning coal in these kind of power stations, end up in huge heaps, and it's been so beneficial that in fact there's a shortage of fly ash. They need to maybe build more power stations so that we can get more fly ash. So for example, PPC's Shearboard 42.5 MPa is an example of this new generation cements, where using the same product and through improving the technology of cement production, grinding it finer and adding certain kind of extenders, you can get 26 to 33% more concrete yield. It means that for using the same amount of cement, you can make 26 to 33% more concrete. The other thing is that they add limestone and they fine-tune it by adding the recipe, sort of adding blast furnish and slag and fly ash to create a better workability, so you've got a better concrete, and also that you've got very early and improved late performances. So this is kind of a typical example of a new generation of cements that's coming out, which are much better than, say, even the cement that you could buy 10 years ago. So concrete, and just looking at aggregates, I think it's important that concrete, if you know about concrete, that the majority of the volume of concrete, in fact, is aggregates. And the average value to produce aggregates is around about 5 kilograms of CO2 per tonne. But aggregates are high volume, low cost materials. It's efficient and sustainable to extract and close to the communities where they are to be used. And that's why you see quarries everywhere that you go. I think what is very important is that contemporary concrete technology is largely driven by admixtures. And admixtures are fantastic stuff, because adding a little bit of chemicals, you can create a huge variety of different kind of effects to that concrete. And you can use it to control the quality of concrete, such as workability, pumpability, durability, the aesthetics, as well as the cost effectiveness. And it's got a massive effect on sustainability. And you can reduce, if you use admixtures, you can reduce your cement content by up to 15%. So that's another way of reducing the cement content of concrete. So just let's have a quick look at some of the responses in terms of innovative cement and concrete products. And I think it's important to note that, in the future, I think innovation and development of low carbon substitutes will drive new age building materials. And I think that's true for all building materials across the spectrum. And of course, it's about optimizing your performance, creating, in the case of concrete, sort of green concrete through high quality cement, as I showcased you with the high Shearbold at 42.5 MPa. That's Johannesburg, by the way, and I'm very happy to say, if you think about PPC, it's been going around. Started the first factory in 1892, So it's a truly South African company. It's been here, and I think I can say that VPC, in fact, has built the foundation of modern South Africa in terms of our cities and in terms of our infrastructure. So what are the key decision makers, priorities? How do we reuse the building in terms of retrofit and city regeneration? How do we reuse the building components and recycling of the concrete and materials? So in terms of sustainability, I think it's important to know that concrete, because it's a very dense material, when you do your passive energy design principles and the strategies around it, is to keep the thermal mass and qualities of concrete in mind, because that way you can control the comfort levels of your building inside. It means that if it's cool outside, your building can be warm inside and vice versa. So in terms of innovation, I think there's some couple of fantastic new things happening. For example, you get this kind of new lightweight sandwich concrete panels. It's available in South Africa. And if you just look at this, this is one of the materials called MIBT. If you look at a 75 millimeter concrete panel, it gives you a 1.79 U value, whereas a 230 clay brick will give you 1.2 and a cavity brick will give you 1.88. So it means that you can go much lighter using much less materials to create buildings that perform far better in terms of thermal performance. This is a case where it's a social housing project in Spain done by Dos Masunu Architects, and here what they did is they did a concrete core and they used the sandwich panels to create these clip-on boxes. In this case you can see that's a 1-bedroom, a studio apartment, 2-bedroom. I thought it was a very clever way of playing with design flexibility. Some examples of that. And I think it allows you certain design flexibility, and of course it influences the cost of the building. This is Mick Pierce. You will be able to hear him if you come to the Architecture ZA in November. And you might have seen this building. It's the world's first 6 Green Star rated building. In fact, South Africa just got its first 6-star rated building in Cape Town, called the Tree Silo project in the waterfront, where we took old silos and refurnished and retrofitted them to become a mixed-use building. In this case, the building on the west side obviously used sun panels to control the sun. On the north facade, using plants to cool the building down, balcony spaces and deep recessed windows to prevent sun from entering the building. And then on the south side, having these huge kind of shower roses. So what happens is that grey water gets channeled to the top of the roof. It sort of sprinkles down these sheets. As it sprinkles down, it cools the air, sucking hot air out of the building on the south side. It gets collated at the bottom, gets recycled through a reed bed, and becomes irrigation for the adjacent gardens. And then back to the north side, there you can see they've got these kind of shafts which is slightly tapered. So you've got sun shining on it. The hot air rises, it sucks more hot air out of the building. Because it's tapered, it accelerates and it turns these turbines, which generates all the electricity that the building requires. So I think this is a prime example of a zero net energy building. Being at the coast, I think you would enjoy this. Driving this morning from Port Alfred, I saw all those, what we call dolisa, as a way of kind of protecting your coastline. In this case, in Mexico, they had a problem with the coral reefs, where tourism and pollution have damaged some of the coral reefs. And James Taylor, who's an English sculptor, decided he was going to intervene. And what he was going to do is he created the first stage, a series of underwater sculptures using a marine concrete. And the sculptures were actually life-size, real-life kind of people depicting the diversity of the population of Mexico. So the first installation was creating a work of art. Of course, being a marine concrete, what happens is that these sculptures are now slowly being transformed. Little things are attaching themselves. And so what you're getting is you're getting the sculptures going from works of art to man-made coral reefs. And I think that's very cool. I think reuse and retrofit is the new language, and I think when you look at that, when you design a building, you've got to keep that in mind to allow the building to be able to be retrofitted or recycled in future. And of course, by using a concrete frame, beam and slab system and column system, you can reclad it. In this case, you can see a building where these are precast concrete panels, so you can, just like a jersey, you can take it off, and you can put a t-shirt on, or you can change the building inside through drywalling, keeping the basic frame intact. In New York, this was a fantastic project, the High Line. You might know about it, but what happened here was it was the old warehouses, a bit like what you've got here in PE by your existing harbour, where you had warehouses and ships coming to fetch stuff. At one stage, this is the main contact point between imports and exports into America and between Europe and America. And of course, it became so hectic that there were numerous accidents with cars and trains were crashing into one another, and at one stage you had cowboys kind of with whistles and horses trying to separate traffic. Eventually they decided to build a railway bridge linking all these warehouses on the harbour side and separating the traffic from the trains, and that fell into disuse. That whole area became very derelict with abandoned warehouses, a dead space, a no-go space. The so-called meat packers district, it was a no-go area, except if you were a drug addict. And so they wanted to demolish this, but through a very wise and clever visionary kind of master plan, they decided to reuse this existing railway bridge by creating the urban park, which would allow people a green line, a vertical, not only vertical interventions, but a long, thin horizontal ribbon that runs through the park, through that part of New York. And it's amazing when you're there, you can see how people are using it. And the incredible thing about this is that using this like acupuncture, by inserting certain key kind of elements of regeneration, you can actually activate an entire area to become regenerated. Because suddenly it's cool, and this place is now very hip. And you can see all these old warehouses have been renovated and retrofitted into apartments. And in fact, new buildings have been built, and this is the place to be. And that entire precinct, that entire area, they've managed to turn around and create a new focus and a new life, and a new cultural precinct for Manhattan, for New York. Keeping some of the old aspects, you can see the old railway lines, recladding the existing concrete structure with a non-slip precast concrete plank, allowed for that kind of durability. In Johannesburg, we've got the Maboneng district. You might notice Arts on Main, some of you might have been there. There's already, now this is near Doornfontein. I would say 7 years ago, again, no-go area, you didn't go there, even the police wouldn't go. So what they did is some very clever young developer, Jonathan Liebman, went in there, he bought the buildings for next to nothing, and started creating mixed-use retrofit, recycling of components. Started off with, very cleverly decided, we've got to attract trendies and the artists and the creative people here. So you could open a studio here for next to nothing, with art galleries, a nice restaurant, market on Sundays. At this stage, there's over 1,000 people living there. They've just purchased another 26 buildings, and the entire southeast of Johannesburg has become, transformed. And it's just suddenly become a hip and cool place, and all the artists are flocking there. There's lots of architects practicing there. And it just shows you how old, derelict parts of the city can be recycled. Keeping the existing structures, reducing the building cost, retrofitting it, adding new uses to it. It is possible for any area, it doesn't matter how bad and what state it is, to be turned around. So in terms of concrete technology, I think it's important, as I said to you before, by using admixtures and things like fibers, you can create high-performance concretes, which means that you can go thinner and thinner. This is an example of a concrete panel. Or for example, this Peace Bridge in Seoul, it's 122 meters wide, it's a ceremonial bridge. Here they used 145 MPa strong concrete. And what is amazing about it is the slab in the middle is only 7 centimeters thick. So it shows you what you can do with high performance concrete. So when you think of concrete structures, you think of big, bulky, huge, boring grey stuff. You can go thin, super thin, and very elegant and very sexy. What I like to call high performance self-leveling concretes, that's basically self-leveling concretes or fluid concretes where you add super plasticizers to the concrete. It means the concrete just flows without having to add additional water to it, and you get a fantastic finish. And you get a strong concrete, which you don't need to compact or vibrate, with a superior finish. For example, this is a new house in Cape Town. It's under construction, done by Free Space Architects. Here they used self-leveling concrete. You can see the fantastic finish that they managed to achieve, but look at how thin the slab is. So you can go thin, and you can create concrete that's basically blemish-free. Some examples of that. This building was amazing to see, the French Pavilion at the Shanghai Expo in 2010. I'm going to hopefully be able to go next year. There's a new expo in Milan in 2014, which should be fantastic because the whole emphasis is again on green. At the Shanghai Expo, a lot of the countries put up pavilions that looked at sustainability, that looked at aspects like zero net energy. And I think that's a word that you're going to hear more and more in the future. That's going to become the challenge of future buildings, is to design buildings that are completely off the grid, or if they're on the grid, they give as much back as what they take to consume. In this case, the building used, the whole structural system was these very thin 12mm thick precast panels that U-channels are clipped together, holding the whole building together. And then the building was completely covered in green, starting with a living roof, and then playing in the tradition of the French garden, the traditional French garden, creating these vertical kind of landscaped ribbons that tie down in the courtyard space with water. So it was amazingly cool and amazingly comfortable inside that space. Outside of the building, and of course you could see the Chinese couldn't resist but to put their flag in front. The Italian Pavilion was another example, again, I think, of looking at creative kind of implementations, creative strategies to create buildings that can reduce the energy consumption. In this case, a close-up, it's a precast panel with polycarbonate chips using a fine concrete mixed without big aggregates, which means that the building becomes transparent, so you get light coming through those polycarbonate chips to allow less energy requirements at daytime, and at nighttime, of course, you've got this wonderful building glowing in the dark. In terms of retaining walls to prevent erosion and to reduce erosion, and also to rehabilitate previously damaged embankments and riverbanks. In Johannesburg, I've just started doing a lot of green walls now. I don't know about PE. It's certainly becoming something which we can see more of in the future, not only the idea of a living roof, but living walls, which allows buildings to literally have a green coat. Not only does it improve the thermal performance of those buildings, but I think it creates a certain aesthetic. And I also say there are so many ugly buildings, for God's sake, just cover them with plants. It's the only way. So even in Sao Paulo, I saw a lot of buildings where they just cover the buildings in plants, and it's amazing how you improve the comfort levels inside those buildings. Because as you know, plants absorb heat, they absorb noise, and they absorb pollution, and of course, they make oxygen. Even in terms of interiors, it's another way of creating sort of improve the quality of your air inside the building is by having internal living walls, which contributes greatly to the quality of the air, but also I think is quite nice to look at. Or rather look at the plant and to look at the ugly painting. Bosco Vertical is about to be completed. It's a new skyscraper in Milan, done by Stefano Burri. And what's amazing about that is the idea that each apartment, each floor, creates a different cantilevered balcony space which can become planted to create literally a vertical green forest building. This power substation in Barcelona, I feel sorry for the architect. I mean, have you ever had to design a power station? Basically, it's a box. So anyway, he decided he was going to do something about it. He had it cast in situ in pigmented ochre concrete, had the entire building covered in a grid of stainless steel cables, as you can see close up. And as I said, what do you do with an ugly building? You cover it with plants. And I think it's a great way of creating green focuses in a otherwise concrete jungle. This football training center in France, again, what I love about it is the way that you can start integrating your landscape with your buildings. And the idea of kind of building slip under the landscape and becoming part of the landscape, I think, is something that should be encouraged. In this case, what otherwise would have been an ugly kind of pimple sitting next to a sports field, just taking the sports field and wrapping it over the building. The future, I think, is to create precast elements, precast concrete elements, which means you can go much thinner, far more accurate, and it's very cost effective. You don't have to wait on site for somebody to finish something. You can have it made off site in a factory and shipped over and assembled very quickly. This is a church in Mexico. I went to Mexico 2 years ago, and I discovered they've got 132 different kinds of tequila. And Merwe is like subtropical and fantastic climate, so you need to drink a lot of liquids. And in this case, they wanted to do a church at the seminary, and they did the entire building using precast elements, clipped the building together, and it was about a 30% reduction, not only in saving building costs, but also in the time to construct it. You can see some of the shots there. I'm all for recycling, and if you can't recycle your plastic, use it as aggregate. And if you can't recycle your glass, use it as aggregate. So I want to encourage you guys to experiment. You can basically use anything as an aggregate. Obviously, you've got to check some kind of chemical reactions, but experiment and play with it. In this case, we did a workshop with students a couple of years ago. They mixed it with paper, and they burnt the paper to create concrete lampshades. So I encourage you, as I say, to experiment with. If you think of cement, it's basically like glue. You can throw anything in it. Here's an example of using recycled concrete. In this case, creating these Gambian walls, kind of energy heat traps to warm the building. And then the front part was precast concrete panels to create the idea of a curtain that slides open. In Cape Town, you might have known that those cooling towers on the way to the airport was kind of keeling over, looking a bit dangerous, and they decided to demolish it. A company called Cape Brick went, they took the concrete, they crushed it, they recycled it, and they created concrete bricks, which was then used to create social housing on the Cape Flats. Actually, you can see it if you drive next to the highway on your way to Cape Town. So on that note, I wanted to show you the experimental concrete. This building was done in 2002 for the Jubilee of the Catholic Church. Not that they need more buildings in Rome, but anywhere, more churches in Rome, they did it. In this case, they decided to use precast elements, Richard Meyer, the architect, and they used Carrera marble as an aggregate, and they added titanium dioxide, which is a fantastic mineral. You're going to see lots of it coming through. You can already get self-cleaning glass and self-cleaning concrete, because what happens is titanium dioxide changes its loading when you put energy onto it. So the moment the sun shines on it, it changes from positive to negative, and it literally pushes pollutants away. So even in Rome, with all those Fiats and Vespas, you've got a fantastic version white building. Now this looks a bit like a alien photo of an alien egg busy hatching. But what it is, in fact, it's called self-healing concrete. It's been taken under a photo, and what they do is they add a certain bacteria into the concrete mix. When concrete, say, cracks and water pours in, it activates those bacteria. Those bacteria become alive, and they secrete calcium deposits, which stitch the concrete together again. So you can create concrete that heals itself. think that's fantastic. The other thing I want to say is that they did some research and they discovered that concrete actually acts as a giant sponge. It reabsorbs CO2 back out of the atmosphere, it soaks it in, absorbs it back into, and you don't have to remember that formula, but it reabsorbs it back into the concrete as part of a continuous hydration process. So over a period of 70 years, concrete will carbonate up to 50% of its volume. So the more concrete you're going to use, the more CO2 it's going to absorb. This is a new building that's still under construction in Cape Town, Portside Place. It's a 5-star, Green Star rated building. It's going to be the tallest building in Cape Town. They used PVC cement here. It's a 52.5 cement, which means it's 52.5 MPa, so it's a high performance concrete, which means that they could go very thin in terms of the structural elements. But also what is important is that they actually extended the cement by 65% slag. In other words, the waste product, 65% of the volume of a concrete is a waste product. So that's the way to go, and on that note I want to say thank you for listening to me, and I want to ask you, how sustainable is the world without concrete? Thank you.
Thank you very much, Daniel. I don't know if anybody has any questions for Daniel regarding concrete. There's one at the back.
Sorry for today. I know his buildings. How does he get such a thing? Look at his buildings. Like his concrete work is amazing. How does he get such things?
Yeah, firstly, you know the Japanese are perfectionists. Okay, so concrete is unforgiving, so it takes in the characteristics of its maker. So if you're going to have bad and shoddy formwork, you're going to have bad and shoddy concrete. So what they do is they basically use steel formwork, they make sure it's perfectly sealed, and of course all kind of neat and tidy. And the other aspect is that they've been using self-compacting concrete, was actually invented in Japan. So most of those buildings you see are self-compacting or self-leveling concrete. As I said before, you can make your own, called high fluid concrete, by adding super plasticizers to the mix. So it's a combination of different elements. I think you've got to design your formwork almost the way that you design your elevation. Where would the joints be? What kind of formwork would you use? If you can use timber formwork, it will be different, say, if you're going to use steel. And in South Africa, I believe what the Spanish do, they say go rough. You know, we can't get it perfect like the Swiss or the Japanese. So they cast it roughly, and then it becomes part of that aesthetic, or they just attack it with jackhammers and chip it like stone. So you can basically do anything with it. That's why I like to call it the liquid stone of the 21st century.
Thank you, Daniel. Is there any other? Did that answer your question?
Yes, thanks.
Are there any other questions for Daniel? Oh, thank you very much, Daniel.
Thank you.